Oh, hello Jenkins. What time do you call this? You've been hanging around with that Polytechnic lot by the look of your clothing. What's this? Pronouns you want to be known by? Them, those, they, Jaffa Cake and Chocolate Unicorn. Come with me. Come on. We're not having this. Right, here you go Jenkins. Take this and have a little think on about your actions. There you go. And when you've changed your mind, ring the bell and I'll come and get you out. Hello and welcome to Tweed's Garage. In this episode, we're back on the Bantam. Yay, say the BSA boys. Boo, say the Riley lot. Never mind Riley lot. More Riley stuff coming soon. Okay, so what have we been doing? We've been carrying on with the crank rebuild on the Bantam, doing a little bit gearbox work and a little bit of work on the rear wheel speedometer drive. So, grab yourself a brew, get yourself comfy and run VT. So we managed to get the main shafts into the flywheels. As you will see, they took a bit of effort to get in. I did sort of freeze them first to try and shrink them down a bit, but I don't think it made a lot of difference. I made some mandrels to help push them in. That one for there, that one for there. But they took about 8 tons pressure to get them to shift once they started getting about beyond halfway down. And the trouble is then they would wouldn't do anything, and then they'd go with a bang and they'd go beyond the point you wanted them to go beyond. So I turned up a little button for the height that I wanted to get them to go down to just stick in the bottom of the flywheel and sit down there and act as a stop. And that worked okay, that worked well. But I made these mandrels from just mild steel. I think it's sort of hot rolled stuff. But as you can see, amazing the pressure of the hydraulic press. They actually belled out over the shoulder. You know, you'd think with a sharp edge it would sit down on that, but there is a little bit of a taper to the side. But there is, you know, there is a shoulder there. But no, it sort of belled out beautifully. It doesn't really show on the camera. yeah, if you ever wanted to bell a bit of steel out, bung it in the hydraulic press on a taper and comes out lovely. So then, because this had sort of belled out a little bit and I hadn't got it down to where I wanted it, I turned a sort of collar up to put between here and the crankshaft and carry on pressing. And even that, look at this, look at the taper it put on that. In the end, he says, squeezed it right out. So yeah, it's amazing how much effort you need to push these things in. And in the manual, it shows it, you do it by hand. Where is it? Let's have a look. Here. Just with this little hand press here to push them back together. Mind you, it does show you just doing the crank pin and not the shaft, so maybe they use something else for that. Anyway, those are in and set and look nice and straight. And then we press the crank pin in preparation for putting it all back together. That goes in a lot easier than these did. So with the crank pin in this side of the flywheel, we need to press it into the other side of the flywheel, not forgetting to put our new rod assembly in. So this is the new one to go in. It does differ from the old one. This is the old one. As you can see, it's got a lot big end on it. These apparently are modified MZ items. So yeah, you get a modified crank pin as well. Slightly smaller journal. There's the old one. A lot bigger. That one. But you can get the original ones. You can send them away and get them re-bearinged. But it's hugely expensive. So, you know what a Bantam is. So this will do the job just fine from a sort of a well-renowned Bantam supplier of parts. So we'll go with that. So going for a smaller big end gets around the problem of this worn ridge in the flywheels, because the original one ran in there like that. So there's a little bit of side play. But because this one is smaller, that will actually run on the original face of the flywheels. So as I said in a previous video, I don't think this is a problem. It's not going to be a problem. So when pressing this together, I explained it in a previous video, but the two things we want to do when we push it together is it can go out two ways. We can either get the flywheels out of line of each other, so I don't want to get it stuck, like this, offset one side or the other. That's easy enough to check. You just hold one end and clock it, and the higher side will mean that you've got to knock this down in comparison to this one to bring it back down into line like that. And then the other problem you can get is you get them either sort of pushed in like that or pushed out like that. So to get that back in, you'd put these two faces in a vise or a press, give them a little pinch that way, and if they're facing inwards like that, then you'd put a chisel or a drift in between the two and give them a whack and try and spread them back out that way. So that's the basics of what you're looking for. What we'll do is we'll set it up in the press, and we'll use a square against the two outer edges here and here to check that these two faces are as in line as we can get them, and then we'll start pressing it down, press it halfway, and we'll pop it in the lathe and check to see what run out we're getting and if it needs any bumping one way or the other, and then we'll pop it back in the press and continue to push it all the way home and then check it again. So hopefully doing it halfway and then all the way, and adjusting it will minimise the amount of adjustments we have to do at the end. So to push it together, they have a special jig, or BSA had a special jig that it sits in, and you put a bar across here and you're sort of pressing down. You're not sort of pressing down about here, you know, because the flat bar goes across there. So sort of no matter where you get it, you're not really getting on the centre of the pin, the outer edge of the hole that you're pushing down over the pin. So what I've turned up is a little mandrill, another one that will probably get squashed to death. But the good thing about it being softer than the crankshaft material is it doesn't do any damage. So there's a little rebate milled on the back of it and a footprint to go round the hole and clearance for the crank pin to come through, because they don't sit flush, they do come through like that. And then that will sit on there quite nicely like that, and then the bottom will be supported, and we'll be pushing hopefully straight down to try and keep it as straight as possible. Right, let's go and see what disaster we can do on this. Oh, what we will be doing on the crank pin and on the bearings on there, we'll be using this graphogen. I've had this years, bought it from I bought a rebuilt A-series bottom end from a racing engine specialist that used to be in Cove in Farnborough, and he recommended this when sort of reassembling the engine, and I've had it ever since. I've used it on the Riley when I put all the Riley together, and that's been sort of running really nicely. So it's just a graphite paste, but the good thing with it is, unlike some of the thick assembly oils you get, which will eventually drain away when it's left over time, this stuff just stays where you put it until the day that you come to actually start the engine and you know, and run it. So it sort of reduces the amount of damage you can cause on a sort of cold start on a new build engine. So we'll put a bit of this on the crank pin and on the bearings in here and in there as well, just to give it something to run on until the two-stroke oil gets all the way around. I will put a little bit of two-stroke oil on them as well, but this is just to sort of back up if it takes me a little while to get around to starting it. To the press. Right, here we go, let's press it all the way home. I'm just hoping that this crank hasn't been built up out of two flywheels and we're just sort of wasting our effort rebuilding this one. But we'll put it together and find out. As many people who mess with these Bantams know, that wouldn't be unusual. I know if you see Dean at Retro Mechanica, some of the cranks he's been fiddling with and rebuilt, he's had the same problem. Spend all that effort and then find, you know, the halves are mismatched and you're just losing a battle you're never going to win. A lot of the YouTube videos on crank reassemblies tend to be Japanese single cylinder two-stroke bikes, and of course their engineering tolerances are a lot better, so they just seem to sort of come apart and go together a lot easier than this. Anyway, stop moaning, get on with it. Give it a little more just to make sure it's home. Leave it for a minute. Conrod moves fine. Okay, well at least it looks like a crankshaft again. And then I'll go and do a bit of fiddling around with it and see where we've got to. No, I'm not going to show you because I need quiet in the room. I need to concentrate. So go and do something else. Okay, you rejoin me after a couple of days of frustration of trying to true this crank up, and got to a stage where I was happy with it, but then I wasn't happy with it because where I'd been tapping it at the bottom and spreading it out, and then I had to adjust it at the top, it had sort of walked its way along the crank pin a little bit. So I've pressed it back together. What else was a problem? These bearings should sort of be a nice sort of slide fit onto the shafts. This shaft was really tight. I had to sort of press the bearing on, which you shouldn't need to do. They should just be a sliding fit. So that allows you to sort of work out your backlash and shim out the crank when you put it in the crankcases. So popped it on the lathe, and with a diamond lap and some emery paper, I took this sort of outer diameter down just to shave, so a sort of bearing will just slip on there with a bit of a push. So that's sorted out now, so happy with that. The way to do it is put the bearings on. That's another reason for the sliding fit, so you can slide these on easily and put it on a jig. It doesn't have to be resting on bearings, it can be in V blocks, and then you put it on your bearing surfaces sort of here and here, and check your run out. Now here we go, so we've got it set. It's not too bad at the moment. It's about 0.15 that side, which is 6 thou. The tolerance is 2 thou or below, so this is out of tolerance this side. Move it over this side. There's about, yeah, just over 0.6 that side as well. So well out. But if we check where the high spot is there, just there. And that noise there, can you hear that? Sounds like the whistle on Titfield Thunderbolt, if anybody's seen that. Right, so yeah, moving away from that. So high spot is there, which is opposite the crank pin. Crank pin's here, so this is the high spot. So this indicates that this shaft is pointing that way, like that. And it's the same on the other side. The high spot's in the same place, opposite the crank pin. Try and keep you in the picture. So low spot, high spot there. Yeah, directly opposite the crank pin. So what we need to do is spread the flywheels here. So we need to hammer there to sort of push it out that way. Now, where I've been doing this, I've been going very gingerly with my little aluminium drift and a copper mallet like this. To no avail really, it wasn't going anywhere. Where's it gone? Oh, it was something like this that I'd milled down that would fit in there. But that didn't do anything. And then the other thing I tried to do was to try and stop it creeping along the crank pin, was to sort of grip this end in a vise and then tap it up here. But that didn't seem to work. I think what it done, it spread it there, and then when you released it there, that allowed it to walk up the crank pin. So what we do now is, it's quite brutal. Got one of these, an old ball joint splitter, so handy over the years, this tool, and copper mallet, just to persuade it. Rest it on a wooden block with the crank pin down on the floor, and then pop this in like that and give it a good tap. Sounds brutal, but off we go. Better already. So we've got .06 that side, so just over 2 thou. 0.12 that side, so about 5 thou. So, and yeah, just keep going, tapping and cracking and remeasuring. Okay, so we spent hours and hours and days thumping, whacking, twisting, bending, squeezing this crank, and we finally got this side on the end of the bearing surface on that side of the crankshaft. We got it to 2 thou. I changed to an imperial gauge, it's just a lot easier rather than have to keep converting it into thousandths of an inch. Now on the other side, there we go. we got just over 1 thou on that side. So not 100% happy with it, but I'm going to call it done, and it's probably as good as a Bantam crank gets. So onwards we go. So time for a little breather. Here's a little walk around the Norton stand at Goodwood Circuit Revival last year. It's been stuck in my library and I just found it and I thought you might like it. So here you go.
I got mixed nuts and raisins, salted cashews, got my famous salted peanuts. I got 3 bags full.
So the next job was to start degreasing and cleaning the crankcases, because I had to do a bit of welding repair on the alternator side on the left crankcase, because it sort of had a bit of damage on it, and also it's sort of been mullered over the years, so it sort of, there was gaps all around it and muck was getting into the alternator area, so I wanted to try and correct that, so to try and keep the dirt out of it. So first thing was sort of to degrease the crankcases, just washed them out in some degreaser, and then to get all the old silicone off, I used some plastic razor blades. Plastic razor blades, you say? Yes, plastic razor blades. I never knew about them, but sort of discovered these. You can buy them on eBay and Amazon, so sort of a little plastic razor blade. I mean, you won't cut your skin on it. Well, you would do maybe if you've done it really, really quickly. But handy for getting stickers off glass, and but very good for getting sealant, gasket sealant off of aluminium crankcases or surfaces without damaging the aluminium, because no matter how careful you are with a piece of aluminium sheet or something made up as a scraper, you still can gouge the gasket surfaces if you're not too careful. So these work really well. They're relatively cheap, buy them by the 100, throw them away when you don't need them anymore, and yeah, they work quite well. So cleaned off the old sealant, and then in the cases are two phosphor bronze bearings that hold the what will this be, the intermediate shaft in the crankcases, and there was sort of a lot of play and a slight ovaling of the bearings that were in there. So what we done was warm the crankcases up a little bit, and then with a internal bearing puller, which is a handy tool to have if you have one lying around, pulled out the old bearings. What do? Well, we've got some hollow phosphor bronze bar, so it just saves wasting a load of material when you drill out the end of solid bar. So it's sort of it's a more economical way of doing it. So yeah, got a section of that, and popped it in the lathe, and then started to turn the sort of top hat outside profile first. And then with that done, drilled the centres out to sort of just below the fit that I wanted, and then went in with a boring bar on the lathe to bore them down to diameter, and then just checking the fit as I went along. So with the internal diameter machined out, it was just a case of parting them off to the correct height. So, and with that done, I've got ended up with my two bearings, but as you can see, they've got oil ways, 3 oil ways on each of them. On the inside, 1, 2, 3, and then one of the oil ways has a little sort of lead-in oil groove on the outside face on each of them. So what I've done to cut these was ground up a tool to go in the lathe, and then just use the top slide to move the tool in and out, gradually working my way in to cut each of the oil grooves, and to get them equidistant apart because there's 3 of them. There's 3 jewels on the chuck. I just laid my engineer's level on the jewels of the chuck, put it in a low gear, turned it round until the engineer's level was level, and proceeded to cut the groove, and then just moved it round to the next 2 teeth on the jaw, levelled it again, cut the next one, and then cut the last one. And then with the last one cut internally, just turned the tool around and used it to cut the slot on the bearing face. And they turned out quite well, even if I say so myself. So we've got new bearings there, ready to be pressed into the crankcases when I've finished repairing them. So I rebuilt the back wheel in the same way as I rebuilt the front wheel. You can find that on an earlier video. The only difference with the rear wheel is you've got the sprocket on it for a start, but also it's got the speedometer drive that sort of bolts to the outside. There's a spacer between it and the inner bearing race, and then a nut that goes on outside that clamps it and the spacer to the inner bearing race. The spacer wasn't big enough. With the spacer too short, it was allowing the speedo drive housing to be clamped tight against the outer surface of the bearing, the wheel bearing, which basically locks the whole back wheel up. So it's sort of going around with the nut not done up tight, which is not good practice. I did have a look in the parts list for maybe there was a washer missing between the spacer and the speedometer drive, but it doesn't show one. So I think at some time it's just worn away. It's either worn away or, like we're finding on a lot of things on this bike, it may have been too short in the first place. So the easy solution was just to make a slightly thicker spacer. So I just worked out how much bigger it needed to be to give us clearance, turn that up, pop that on, job done. Now on the diagram it does show an oil seal that goes around this spacer, but I've changed, the original bearings were open bearings and I've gone for sealed bearings on all the wheel bearings, so that's not an issue really on the back. I might stick one in when I find one, but it'll do for now anyway. So there you go, bit more work on the Bantam, crank back together, and we're working on the crankcases, so getting close to starting to put the engine back together, thank God. Anyway, so if you found it interesting, give us a little like, and if you want to see more, subscribe. And oh, hang on a minute, I think he's ready to come out. Okay, so next time, bit of Riley, but until then, I'll see you next time. Okay, all right, hang on Jenkins, I'm coming. Silly sod.
Yo voy a cantar esta canción, yo voy a cantar esta canción para mi gente.
Right, Jenkins, what time do you call this? You've been hanging out with that Polytechnic locker.
Con una pasión tan fuerte.
So, right, time for a little breather. Here's a little wander around at the Norton stand last year at see more, subscribe. That's that out of the way. He's just sanding next door. Finished. So there you go. A bit more work on the Bantam. Getting close to getting ready to put all the components